When we go to report geographic coordinates or lat longs, there's two different systems that are commonly used. Degrees, minutes, and seconds is one. Decimal degrees is the other one. Now, with degrees, minutes, and seconds, you end up having the degrees, and then you have seconds, and then, minutes, and then you have seconds. The seconds will range from 1 to 59. 60 then flips over and adds 1 to the minutes. Minutes will then go from 1 to 59. When they go to 60, that will add 1 to the degrees. In other words, there's 60 minutes per degree and 60 seconds per minute, just like on a clock, except the latitudes again go from 90 degrees in the south up to 90 degrees in the north. Similarly with longitude, the minutes and seconds are the same, but the value of degrees goes from 180 in the west and around to 180 in the east. This is the older system, and you do tend to see degrees, minutes, and seconds with the N and the W, or the E and the S, depending on north, south, east, west. So those tend to go together. And almost always what we want to do is we want to take those and convert those to decimal degrees. This is where the computer really likes these values more. It's used to working with floating point numbers. They work better. So we'll talk about converting those in a second. One thing that's really important is you will see different formats for DMS. This is the old traditional one. You may hear it in movies. But you'll also see this, which is a bit more archaic, or obscure, hard to tell what it is. Or this, which starts to look like something else. And once I got a data set look like this, which I immediately thought was eastings and northings from a projected system instead of geographic coordinates. And it took me a while to realize, largely because none of the values here had anything over 59 in them. And also the coordinates just didn't make sense as any projected system I could come up with. So I realized they were geographic without any of the notation. So be careful with that. The conversion to go from DMS to DD is very simple. You just take the degrees plus the minutes divided by 60 plus the seconds divided by 3600, and that'll give you the decimal degrees. So you can do that in Excel. There's also websites where you can do it, but if you need to do a whole bunch of data, you can just do it as an equation in Excel. Here's some examples. Now, another really key important thing is that we will lose precision with DMS. Okay, we need to keep an additional digit after the decimal. Okay, now the reason for that, really two after the decimal, is because the Earth, and this is a really good number to remember, the Earth's about 40,000 kilometers around at the equator. Okay, if we divide that by 360 degrees, that means the Earth is about 110 kilometers per degree. If we divide that by 60 minutes per degree, we get that there's about 2 kilometers per minute. Again, dividing by 60 seconds per minute, that means there's about 0.03 kilometers per second, or about 30 meters per second. And in fact, you will see a lot of data sets like Landsat that's 30 meters per second resolution. The pixels are 30 meters on a side. This is why. It's because 1 second on the Earth's surface in DMS is about 30 meters. Now the problem with that is if we have degrees, minutes, and seconds, and there's nothing after the decimal for the seconds, that means we have data that's only accurate to 30 meters, which is usually not good enough for natural resource applications. If we add another digit, we're down to 3 meters accuracy. So that's close, but we really need 2 to get 1 meter of accuracy, and that's what we like to keep. So you need to remember to keep 2 digits after the seconds decimal. Okay? Now, once in a while, I also get people sending me data sets that literally have whole degrees. In other words, they don't have any minutes or seconds. So it would just look like 40 north or 124 west. Since each degree is about 110 kilometers, that means that our accuracy is 110 kilometers. So it's basically useless data, and you've got to go back and find the original data and hopefully get that additional accuracy. Okay,